Good morning from Florida's Space Coast, where you're looking at a live view of Space Launch Complex 46 this morning, where Astra is set to launch its small satellite launch vehicle during a 2-hour window opening at 12 p.m. Eastern Daylight Time, or 1600 UTC. This mission will be deploying the first two of 6 Tropics hurricane research satellites for NASA. These satellites are relatively small, each about 11 pounds or so in weight at liftoff, and about the size of a loaf of bread. But they pack a punch in terms of technology with a miniaturized radiometer instruments on board to scan tropical cyclones, studying their temperature and moisture content to help forecasters develop better predictions of intensity and track for hurricanes and tropical cyclones around the world. This view of the launch pad comes from a location near Cape Canaveral, near Jetty Park, a few miles to the south of Pad 46. Astra's rocket is relatively small by launch vehicle standards. It's about 43 feet in height, or 13 meters tall. And you can see that vehicle just sticking up in between the 3 lightning towers with the flashing lights. In between those towers is the small vertical rocket, 43 feet tall again in height, waiting liftoff at the opening of a 2-hour window at 12 p.m. Eastern Time. You can see some boat traffic entering and exiting the inlet at Jetty Park into Port Canaveral. This is located just a few miles to the south of Cape Canaveral Space Force Station. You can also see a few spectators and photographers gathered to view the launch this afternoon. The opening of the window now about 54 minutes and 30 seconds away. A big factor today will be the weather conditions here on Florida's Space Coast. The official weather forecast from this morning indicates just a 40% chance of favorable weather at the opening of the window for a launch today. Toward the end of the 2-hour window, weather conditions are expected to worsen with the development of thunderstorms along the east coast sea breeze here in Florida. And at 2 p.m., the forecasters only expect a 10% chance of acceptable weather. So weather conditions not great. The forecast not ideal for a launch today, but the best odds for liftoff weather-wise appear to be at the opening of the 2-hour window. You can now 53 minutes and 25 seconds until the opening of the window. You can see it is a breezy day today here on Florida's Space Coast as well. But the winds aren't expected to be the major issue. The major issue is expected to be cloud cover associated with thunderstorms that could be building in the area. More clouds have been building throughout the morning. There are currently no rain showers in the immediate vicinity of Cape Canaveral, but that is predicted to change in the coming hours. Now 46 minutes and 45 seconds from the opening of today's launch window here at Cape Canaveral, Florida. You're continuing to look at a live view of Space Launch Complex 46, where Astra's Rocket 3.3 vehicle is vertical. It stands just 43 feet or 13.1 meters in height. Relatively small by launch vehicle standards. In fact, it's the smallest currently in service, orbital class rocket in the world. This mission will be carrying the first 2 of 6 Tropics hurricane research satellites for NASA. These satellites are each about 11 to 12 pounds, or about 5.3 kilograms at launch. NASA has purchased 3 dedicated launches from Astra over last year to launch these 6 satellites on 3 separate occasions this summer. Today marks the first of the 3 launches from here at Cape Canaveral. All 3 will be lifting off from Complex 46 here in Florida. On the left side of this slide is a view of Astra's rocket on the launch pad, and inside the payload fairing that's emblazoned with the NASA meatball logo are the 2 Tropics satellites. On the upper right is an artist concept of what the satellites look like in space, fully deployed. Once they deploy their solar panels and activate their instruments, they'll be scanning tropical cyclones, collecting data on their intensity and changes and evolution, with unparalleled revisit rate of about once every hour. So scientists will be able to see what's going on inside tropical cyclones about once every hour. Currently, similar instruments are flying on satellites in polar orbit that only allow about 4 observations of hurricanes per day. So this will be a great deal more data for researchers to get their hands on to study how these cyclones form and evolve. On the lower right is a view from Blue Canyon Technologies, which built the satellites. Of all 6 Tropics satellites, actually 7 Tropics satellites, including an engineering model, a ground model, a Pathfinder satellite, ready for liftoff in their state before they were shipped to Cape Canaveral for integration with Astra's launch vehicle. We spoke with Bill Blackwell, the principal investigator of the Tropics mission from MIT Lincoln Laboratory a couple of days ago, and he talked a little bit about what the mission will be doing and the data it'll be collecting over the course of its 1 year of operations. And the goal is to get these satellites in orbit in time for the peak of hurricane season, the peak of Atlantic hurricane season, coming up in late August and early September. So we'll now listen to that interview from William Blackwell, the principal investigator for the Tropics mission.
Can you tell us a little bit about what the Tropics mission will reveal about hurricanes?
We're trying to make improved observations of tropical cyclones, and what we're really trying to characterize is the fundamental thermodynamic environment around the storm. So that's things like the temperature and the amount of moisture and precipitation intensity and structure around the storm. And those are important variables because they can be related to intensity of the storm and even potential for future intensification. So we're trying to make those measurements with relatively high revisit. That's really the key new feature that the Tropics constellation provides, is improved revisit of the storm. So we'll have 6 satellites orbiting, and 1 satellite will orbit and make a nice image of the storm. And then the next satellite will orbit closely behind it, about an hour behind. So we'll get roughly every hour a new image of the storm. And that's about a factor of 5 to 8 better than what we get today. So with these new measurements of rapidly updated imagery, we hope that that will help us understand the storm better and ultimately lead to better forecasting of the hurricane track and intensity.
And the instrumentation you're using on these CubeSats, as I understand it, similar instruments have flown before, but they're much larger on larger satellites, kind of one-off things. And the advancement in technology has allowed you to miniaturize this technology for the CubeSat form factor, right?
That's exactly right. So NOAA and the Europeans and many others have been flying passive microwave radiometers for decades. And these are big, expensive instruments. And what we've done with Tropics is miniaturize the electronics and make them much smaller and accommodatable on very small nanosatellite CubeSat spacecraft. So the entire satellite for Tropics, one of them weighs about 10 pounds, and it's about the size of a loaf of bread. So these are relatively inexpensive, to build and test. We can make them fairly rapidly, and they're relatively inexpensive to launch. You can launch these on rideshare missions through SpaceX and others and get them up quickly and at relatively low cost.
Can you talk about the types of measurements you're going to be making inside the, looking down from orbit into the hurricane, into the cyclone? Will you be seeing, temperatures, winds? What kind of things are you looking at?
Right. Well, there are a number of things that we're looking at. So I mentioned temperature. So one of the things that we're very interested in is measuring the temperature profile, the vertical profile of temperature in the eye of the hurricane. So the resolution is good enough where we can actually do that with the Tropics satellites. And that temperature anomaly, this warming aloft in the eye, again, tells us something about the intensity of the hurricane. So that's one example. Another example is the moisture in the environment of the storm. Could facilitate intensification of the storm. So we're trying to study to what extent does environmental moisture impact intensification. And then another example is the structure of the precipitation. We're looking at the symmetry in the rain bands and how that might change and how that could lead to better forecasting of intensification by virtue of looking at how that changes.
And all of this data that's collected by Tropics, you mentioned the revisit rate is kind of something novel about this mission. How will this be correlated into forecasting? I know this is a research mission, but it's natural, I think, to talk about how this is going to improve forecasting and modeling. How could this data do that?
Right. There is a lot of interest from operational partners like NOAA and the Department of Defense for using the data from Tropics in near real time to actually improve the forecasting, on timescales that are useful for the operational users. So you mentioned Tropics is a NASA research mission, so we have no requirements to do any near real time processing. However, we are working very closely with partners to certainly do what we can to improve the near real time use. So for example, NOAA and the Office of Naval Research are both funding the Tropics project for augmentations to improve the near real-time use. That's outside of the NASA scope of the mission, but we hope that that will improve the ability of the forecasters, the Hurricane Center and others to use the data in near real time to actually help disaster management and so forth.
You mentioned NOAA and the Naval Research Lab. Can you talk about the partners on this mission and what they're bringing to the table? Who built the spacecraft bus? Who's providing each of the the instruments?
Well, one of the most interesting aspects of the mission to me is the team that is making this possible. We've got a broad array of government labs and NASA, NOAA, and universities and commercial partners that are helping us do all this. So on the science team, we've got NASA and NOAA, University of Wisconsin, Vanderbilt, MIT, and those folks are tasked with doing the science processing, the algorithm development, and the generation of the geophysical products, the temperatures, the moistures, intensity estimates, and so forth. On the hardware side, we built the microwave radiometer payload at MIT Lincoln Lab, and the CubeSat bus was provided by Blue Canyon Technologies in Boulder, Colorado. And BCT is also doing the mission operations for us. And we're using a host of new commercial providers for these kinds of missions. So a company in Norway called KSAT is providing the ground station downlinks. Astra Space is providing the 3 launches that we need to get us into our very specific orbital configuration. So there's really a really great team that's helped us pull this mission off.
You mentioned the ground station KSAT. Getting access to this data rapidly, I would imagine, is a key part of the utility of this data. How soon after data collection will you be able to get your hands on the information gathered by the Tropics CubeSats?
Well, so after we launch the CubeSats, and by the way, they'll be launched in pairs. So the first launch will launch the first 2, and then we'll have 2 go up a couple weeks after that, and the final 2 another 2 to 4 weeks after that. So once we have them up, then we'll go through a process of commissioning. We'll turn on the spacecraft and check out all the core functionality, bring the payload online, And then we'll start to look at the detailed radiometry, the calibration, and start to validate that. So it'll take us on the order of a month or two to work through all those processes for the pairs of satellites. And we're, of course, highly motivated to get the data out as soon as we can, because we're going to be in the throes of Atlantic hurricane season, right? So there's going to be a lot of demand for that data. And that's actually helpful for us to get the data into the hands of the users, who can then tell us if there are things that need to be looked at or improved, or tell us how good it is and what we need to do to make it better, as we're constantly going through these optimizations of the calibration. So we hope to have it out in the manner of a month or two.
And how long is this mission scheduled to last, if all things go well?
Well, our requirement from NASA is to collect science data for 1 year, and we hope to go longer than that. So we've designed the spacecraft to last a bit longer than that, and there's some cases where these CubeSats are lasting 3 years or even more. So we hope that we'll be up significantly longer than the 1 year requirement.
You mentioned the launches are scheduled a few weeks apart, one potentially this weekend, another in a few weeks. Any particular reason why you're wanting to get these launches done in such a quick cadence, from a mission perspective, or is it just that's the way it works out efficiency-wise, is to get them all up as soon as possible?
Yeah, we're motivated to get the constellation deployed and checked out as quickly as possible. So when we have all 6 up there and working together, as well as they can, then we're really, we got the pedal to the metal and getting all of the data in its the best possible configuration. So we're motivated to get that up and running at full speed as soon as we can. So that's really why we're trying to launch them together.
And we've seen a lot of these CubeSat type missions launch on ride shares. You're getting a dedicated ride, 3 dedicated rides actually, from Astra Space. Why not go with a ride share? I know there are benefits to that. There are benefits to a dedicated ride. Can you talk about, there's something about the mission that needs a dedicated ride?
Yeah, there is. So we have designed the mission to use a very specific orbital configuration. And the reason for that is we're trying to optimize the coverage. So we want to be able to cover the entire tropical cyclone belt from about plus minus 40 latitude. And we want to optimize our revisit rate. So we have a requirement to revisit with a median of 1 hour or better. And we also want to optimize our spatial resolution. So taken together, those set of requirements, the configuration works best if we incline our orbits to 30 degrees with respect to the equator, and use 3 separate orbital planes that are equally spaced. So we want to space out the spacecraft as much as we can. We want to keep them over the tropical cyclone belt. And this orbital configuration lets us do that, but it requires 3 separate dedicated launches, as you mentioned.
I've heard from NASA officials that you really only need 4 of these satellites to meet your minimum mission requirements. You only really need 2 of the 3 launches to be successful. This is a little bit different. I know you don't work from NASA, but from NASA's perspective, it's a little different. I think they often focus on 100% mission success. Can you just talk about maybe your thoughts? What are your thoughts on the risk approach for a mission like this, where, we're good enough versus perfection?
Well, one of the things that the constellation gives you is some resilience and robustness to failure. So we've designed the mission from the ground up to build in some robustness to failure. So the choice of 6 satellites was made to give us some margin. We only needed 4 to meet our baseline requirements, so we can tolerate failures of the satellite or failures of the launch or whatever, and we can still meet our requirements. So there's some built-in design to mitigate some of the risks that are inherent in these CubeSat missions, right? Where we don't need a 100% success rate for overall system success, right? So that makes it, in some sense, easier to fulfill the mission, even in the face of some of the challenges for things that might go wrong.
Okay, Dr. Blackwell, thank you for your time.
It's my pleasure. Thank you.
That was William Blackwell, the principal investigator for NASA's Tropics mission. I had the chance to speak with him a couple of days ago as he talked about the mission, the Tropics mission, what the satellites will be doing. They'll be studying, as you heard, hurricanes, measuring different parameters of vertical profiles of temperature and water vapor through the atmosphere. These are key parameters that help forecasters and computer models predict the development and evolution of tropical cyclones. The Tropics satellites will be launched into an orbit about 357 miles or 550 kilometers above the Earth at an inclination of 29.75 degrees to the equator. And in that orbit, a 29.75 degree inclination, the satellites will be passing over regions roughly between 30 degrees south and 30 degrees north latitude, which are the most regions of the Earth most prone to tropical cyclone development. So these satellites are really designed to focus on weather in the tropics, hence their name, Tropics, and we'll be monitoring cyclones around the world. With 6 satellites in orbit, the mission will be able to measure, pass over a tropical cyclone every hour or so. And so with fresh data in their hands every hour, forecasters will be able to look at tropical cyclones with greater regularity and see their evolution strengthening up close more often than currently possible with traditional weather satellites. These satellites initially will be focused on just gathering data and proving out the feasibility of a system to measure these parameters in a constellation of small satellites. Eventually, though, Tropics or a follow-on mission could be used in operational weather forecasting by the National Hurricane Center. Again, 2 of these Tropics satellites are launching today on the Astra Rocket 3.3 vehicle. There are 2 more Astra missions currently scheduled in late June and mid-July currently, with the following 4 Tropics satellites. NASA wants at least 4 of the 6 Tropics satellites in orbit to achieve minimum mission success objectives. This mission is what's known within NASA as a so-called Class D mission. These missions are more tolerant of risk and are generally less expensive than NASA's more costly one-off satellites. So NASA is accepting a little bit greater risk on this mission and is going into the launch campaign setting mission success criteria for 4 operating satellites or 2 successful launches in this 3-launch campaign. This Tropics mission is called, Tropics stands for the Time-Resolved Observations of Precipitation Structure and Storm Intensity with a constellation of small sats, hence the name Tropics. And the mission has a total cost of around $40 million. That includes about $32 million to develop the instruments and satellites, as well as to pay for 1 year of operations once the spacecraft are in orbit, and another $8 million in costs to Astra, the company that was selected to launch these satellites on 3 separate dedicated rockets. Although the weather forecast continues to look iffy during the 2-hour window this afternoon, a snapshot of current weather conditions at Cape Canaveral show all parameters are green at this time for launch. Now, about 26 minutes until the opening of the launch window, propellant loading is now underway on the Astra's Rocket 3.3 vehicle. The Astra rocket burns a mix of kerosene and liquid oxygen propellants on both stages. And those propellants are now being loaded into the vehicle out at Space Launch Complex 46 here at Cape Canaveral, Florida. Now inside 22 minutes until launch of Astra's Rocket 3.3 vehicle from Space Launch Complex 46 at Cape Canaveral Space Force Station in Florida. This image taken earlier this year shows Space Launch Complex 46, which is located on the easternmost tip of the easternmost extent of Cape Canaveral, Florida, on property owned by Cape Canaveral Space Force Station. This launch facility is operated by Space Florida, which is an entity of the state of Florida government that's set up to attract commercial space business to the Sunshine State. And Space Launch Complex 46 is a multi-use pad. This is the second time Astra will have launched from this facility. It launched a package of NASA CubeSats on a mission back in February, but the mission failed to achieve orbit due to an issue encountered during stage separation a couple of minutes after liftoff. This will be the seventh, or rather fifth, orbital launch attempt in history from this pad, dating back to the late 1990s. A pair of Athena rockets launched from this pad by Lockheed Martin back in the late 1990s, followed by a launch in 2017 of a Northrop Grumman Minotaur rocket carrying a military space surveillance satellite to orbit. And then most recently, a mission earlier this year conducted by Astra, and then today's mission, also by Astra, marks the fifth orbital launch attempt from this pad, which is the easternmost pad on Cape Canaveral Space Force Station. Astra ships its rockets to the launch site in conventional tractor trailers. The ground support equipment and the launch vehicle are both sized to fit inside conventional shipping containers. And once this hardware arrived at Cape Canaveral, a small team of roughly a half dozen or so technicians and engineers set up the equipment and raised the rocket vertical for a static test firing earlier this month. And now we're going to play a video of the static test on Pad 46 last week.
10, water on, 7, 6, 5, 4, 3. Shutdown.
That was a view of the static test firing of Astra's Rocket 3.3 vehicle last week at Pad 46 in preparation for today's launch attempt. Liftoff now less than 19 minutes away at the opening of a 2-hour window. The opening of the window is scheduled again for 12 p.m. Eastern Daylight Time, or 1600 UTC. The weather forecast, as issued this morning, was iffy, with just a 40% chance of favorable weather at the opening of the window. However, the latest check, the current check of weather parameters here at Cape Canaveral show all weather rules are green and go for launch at this time. Weather forecasters will be monitoring the conditions throughout the rest of the countdown, though, to see if there are any thunderstorms that pop up in the vicinity that have any threat of lightning, or any cloud cover that forms over the launch pad that may pose a threat to the rocket as it climbs through the atmosphere. The launch countdown for today's launch of the Tropics satellites is now holding at T-minus 15 minutes. We're not sure yet of the reason for this hold. However, the countdown is stopped at 15 minutes. The launch window today extends until 2 p.m. Eastern Daylight Time. However, the forecast worsens this afternoon, and the expectation going into the launch countdown this morning was that the best weather conditions would be available, most likely available, at the opening of the window at noon Eastern. The weather conditions still are all green and go for launch at this time. Astra's countdown continues to hold at T-minus 15 minutes. We're waiting any word on the reason for the hold. Astra has not provided an update on what issue may be currently being reviewed by the launch team. Astra's launch team is stationed at the company's factory and headquarters out in Alameda, California, in the Bay Area. And the launch team out there is actually controlling the countdown and monitoring the countdown, while a much smaller team of technicians is on site here at Cape Canaveral for any hands-on work on the vehicle that may be required for troubleshooting any issue today. Once the rocket lifts off, it will be heading downrange toward the east-northeast from Cape Canaveral. 5 Delphin engines will be ignited on the launch pad. Those will throttle up to produce about 6,500 pounds of thrust each, combining for about 32,500 pounds of thrust in unison to power the 43-foot tall Astra Rocket 3.3 vehicle off the pad. At 6 seconds after liftoff, the rocket will begin a pitch-over maneuver to start lining itself with its planned trajectory toward the east-northeast. In less than a minute, the rocket will be supersonic, and at about T+1 minute and 10 seconds, it'll pass the point of max Q, which is the period of maximum aerodynamic pressure on the vehicle as it accelerates through the atmosphere. Those 5 Delphin engines burning kerosene and liquid oxygen will fire for about 3 minutes before main engine cutoff at T+3 minutes. That'll be followed 5 seconds later by the jettison of the payload fairing. That's the nose cone on top of the Astra rocket. That will reveal the second stage of the vehicle and the payloads, the Tropics satellites, to space for the first time. At T+3 minutes and 10 seconds, the upper stage will be separated from the first stage booster, which will fall back into the Atlantic and will not be recovered. This is a fully expendable launch vehicle. And then at T+3 minutes and 15 seconds, the second stage will ignite its ether engine. This is a small thruster producing about 700 pounds of thrust, 740 pounds of thrust, also burning kerosene fuel for a burn lasting more than 5 minutes. And this burn will actually accelerate the rocket and the Tropics satellites to orbital velocity of around 17,000 miles per hour. And that engine on the upper stage will cut off at T+8.5 minutes. And 10 seconds later, the command will be issued to deploy or eject the Tropics satellites from their container on top of the rocket. And those satellites will be ejected from the rocket and begin their automated checkout sequence. They'll automatically power on and run through some testing and activations. And then ground teams hope to receive signals from the Tropics satellites sometime in the next first day or two after launch to confirm their health and their aliveness after the launch on Astra's Rocket 3.3 vehicle. The countdown continues to hold at T-minus 15 minutes. You're continuing to look at a live view of Space Launch Complex 46 at Cape Canaveral Space Force Station. You can see some crowds are now gathering at Jetty Park. This location is about 5 miles away from the pad, and this rocket is only 43 feet tall. It weighs about as much as a fully loaded Cessna business jet. And this is actually the smallest currently operational orbital class rocket in the world, and the lowest thrust orbital class rocket that's ever flown successfully to orbit. Unfortunately, NASA and the U.S. Space Force are not escorting media to a close-up viewing site for this particular mission to give us a better view of the rocket. We hope that changes going forward for the next 2 Tropics missions. Again, this launch is deploying the first 2 of 6 Tropics Hurricane Research satellites. These satellites will be measuring parameters like temperature and moisture content throughout vertical columns in the atmosphere in the regions inside and around tropical cyclones. And this information will help scientists learn more about how and why tropical cyclones intensify. These two satellites on board this mission are each about the size of a loaf of bread or a shoebox. They weigh about 11 to 12 pounds, or about 5.3 kilograms. Very small satellites collecting these hurricane measurements. NASA has 4 more Tropics CubeSats fully assembled already and ready for shipment to Cape Canaveral for launches in late June as well as in mid-July. The goal is to have all 6 of these satellites in orbit and commissioned and collecting data in time for the peak of the Atlantic hurricane season toward the end of August and in September. This mission will be targeting a low inclination orbit of an inclination of 29.75 degrees to the equator. The orbit parameters for this mission are calculated and set due to the requirement for these satellites to regularly pass over the tropical regions of Earth. And again, the goal of the mission is to focus on the development of tropical cyclones. So in this type of orbit, the tropic satellites will pass over any individual storm with a rate of about once per hour, less than once per hour, or greater than once per hour, rather, about once every 50 minutes with all 6 satellites in orbit. And that's the benefit of these small satellite constellations, is that when you have one satellite, you only pass over a storm a couple of times a day. With 6 satellites focused on the tropical regions, there's coverage over these storms every hour or so. And to reach this orbit, Astra's Rocket 3.3 vehicle will be heading downrange toward the east-northeast from Cape Canaveral. This red track along the map shows the expected ground track downrange from Cape Canaveral from Space Launch Complex 46, which again is the easternmost launch pad here on Florida's Space Coast near the eastern tip of Cape Canaveral. The countdown is resumed now. The Astra countdown now at T-minus 11 minutes and 20 seconds and counting after clearing whatever issue that was being reviewed earlier. So liftoff now 11 minutes and 10 seconds away. Copy that. I guess that's on the stream deck, right? Now 9 minutes and 20 seconds until launch of Astra's Rocket 3.3 vehicle. Liftoff is now scheduled for 12:12 p.m. Eastern Daylight Time, or 16:12 UTC. The issue that caused the countdown hold earlier was a boat in the downrange launch hazard area. That boat is now clearing the area, and the range is currently clear for launch at 12:12 p.m. Eastern Daylight Time. Now, inside of 7 minutes until launch, 6 minutes and 31 seconds to be exact, the final poll of Astra's launch team gave a unanimous go for liftoff. The NASA Tropics CubeSats on top of the Astra Rocket 3.3 vehicle are also ready for launch. Now 6 minutes and 15 seconds. T-minus 2 minutes and 30 seconds. The final range poll showed that the eastern range here at Cape Canaveral is green for launch. Now less than 2 minutes until launch. 1 minute, 40 seconds. Hold, hold, hold. The countdown is holding. The countdown is holding just as we saw a SpaceX recovery boat pass through the channel here at Jetty Park. The countdown is holding just outside of 1 minute until launch. Again, if you're just joining us, the Astra countdown is holding at about T-minus 1 minute and 10 seconds. That hold was called in the final moments of the countdown. We haven't heard a reason for the hold yet. The countdown was targeting a launch at 12:12 p.m. Eastern Time, or 16:12 UTC. The window today extends until 2 p.m. Eastern. Astra's countdown continues to hold. The latest update from Astra Launch Control is that this hold is allowing the team to complete the conditioning of liquid oxygen on the vehicle. This liquid oxygen is the oxidizer consumed by the rocket's engines in combination with kerosene fuel. And the liquid oxygen is stored at cryogenic temperatures of a couple hundred degrees below 0 Fahrenheit. So right now the team is making sure that that liquid oxygen is at the correct temperature and properly conditioned for the rocket to achieve the expected performance during today's flight. Again, all weather parameters at this moment remain observed green or go for launch. The Astra countdown remains in a hold at this time. Again, this mission will be carrying 2 Tropics satellites for NASA. These satellites will be orbiting the Earth at an altitude of 357 miles, or 550 kilometers. You're watching now as a cruise ship passes in our field of view at Jetty Park, looking toward the pad. We expect this cruise ship to pass momentarily. Here's an animation of the Tropics satellites, what they'll be doing in orbit. Each satellite weighs about 11 pounds, about the size of a shoebox or a loaf of bread. The instrument on the satellites is a microwave radiometer that's about the size of a coffee cup, and that radiometer is actually spinning at 30 rounds per minute, about once every 2 seconds. And the 6 satellites will be making repeated passes over tropical cyclones, collecting data on their intensity, things like the water vapor content inside the storms, as well as the temperature at different altitudes in the atmosphere within and around these tropical cyclones. This animation from NASA shows what these satellites look like as they are fully deployed with their solar panels out and their spinning radiometer instruments in action in low Earth orbit. The countdown continues to hold now at T-minus about a minute before launch. We're waiting on an updated launch time from Astra. Once we get that launch time confirmed, we expect the countdown to be recycled back to a hold point, likely around 15 minutes. At T-minus 15 minutes is our expectation. And then the countdown will be picked up from that point and ticked down toward the new target launch time. The launch window today extends until 2 p.m. Eastern Daylight Time, or 1800 UTC. There are some rain showers starting to build inland over central Florida. These rain showers are moving generally to the northeast. Currently, weather conditions here on Cape Canaveral are still go. They're still observed green at this time for a launch, but it remains to be seen if those conditions remain green and go for launch when Astra sets their new target T0, or liftoff time. We're back live now with that cruise ship has passed through our field of view heading toward Port Canaveral. We're continuing to look at a live view of Astra's Rocket 3.3 on Space Launch Complex 46. This view from the beach near Jetty Park at Cape Canaveral, looking toward the northeast, about 5 miles away from the pad. Astra's Rocket 3.3 stands 43 feet tall, about 13 meters in height. It's 52 inches in diameter. It's the smallest orbital class rocket currently operational worldwide. This rocket is just about 20% of the height of SpaceX's Falcon 9 rocket for comparison. So a very small launch vehicle tailored to hauling these small CubeSat nanosatellite type payloads into low Earth orbit. This will be Astra's 7th orbital launch attempt, dating back to 2020. And of the 6 previous attempts made by Astra to reach orbit, 2 have succeeded. So this rocket is still relatively unproven, relatively early in its life cycle. And this mission is contracted by NASA. NASA has contracted with Astra for 3 dedicated launches on the company's Rocket 3.3 vehicle. This is the first of the 3 to carry those Tropic satellites into orbit to begin missions monitoring tropical cyclones. We'll continue to stand by for word from Astra on the status of the countdown and when Astra might make another run at launch today. Again, the launch window extends until 2 p.m. Eastern Daylight Time. The countdown continues to hold now. We're still waiting on an updated launch time from Astra. However, the weather conditions are starting to deteriorate here in Central Florida, with the thunderstorms starting to pop up inland. These storms are heading generally to the northeast, as you can see in this weather radar view from here at Cape Canaveral. Astra says the Eastern Range, the weather team at Cape Canaveral Space Force Station, reports that the weather is expected to remain favorable for launch for about another 15 or 20 minutes. And after that, the weather is expected to go no-go or red for launch through the rest of the window. So Astra is kind of racing against the clock right now to resolve this liquid oxygen conditioning issue, to see if they can make another run at launch today before the weather starts to deteriorate and storms start to move in near the launch site. The launch window does extend until 2 p.m. Eastern Daylight Time, or 1800 UTC. But again, the weather conditions are not expected to be favorable throughout that time period, throughout the window. So Astra expects to have another 15 or 20 minutes available for good weather to get this launch off the ground today. Astra's countdown remains in a hold. This hold was called at about a minute before liftoff, and the launch team for Astra, which is stationed out in California to do remote monitoring of this countdown, is currently working through an issue involving liquid oxygen conditioning to make sure that the oxidizer on board the rocket is at the proper conditions, proper temperature for launch today. Weather conditions remain green at this moment, but there are storms building inland, moving generally in the direction of Cape Canaveral Space Force Station that could pose a problem later in the window. So Astra is hoping to resolve this issue and resume the countdown before these weather conditions turn and go red. The launch window extends until 2 p.m. Eastern Time, or 1800 UTC. You're looking live at Space Launch Complex 46 at Cape Canaveral Space Force Station, where Astra's Rocket 3.3 vehicle is currently standing vertical. It stands 43 feet tall, awaiting a launch opportunity today. Again, NASA and the U.S. Space Force, which typically provide media access to a viewing site relatively close to the launch pads within the safe zone around the launch pad, those entities are not providing any media access to a viewing site with a clear view of the launch pad today. So we're positioned about 5 miles away from the pad at Cape Canaveral on the beach. You're looking generally northeast toward Space Launch Complex 46. Astra's rocket is the small vertical feature visible on the horizon in between the two taller lightning protection towers on each side of the launch pad. So the shortest structure you're actually seeing out toward the launch pad is indeed the rocket. It's dwarfed by those lightning protection towers as well as the mobile service gantry at pad 46. We do expect the rocket to be clearly visible, though, once it lifts off from pad 46. You're now looking at a closer view of Astra's Rocket 3.3 vehicle at Pad 46. This view provided by a live stream from Astra and its partner NASA Spaceflight. You can see the 43-foot tall vehicle standing vertical, venting oxygen vapors. The vehicle is about 52 inches in diameter, and you can see part of the Atlantic Ocean on the horizon there in this view. Again, a closer view of Astra's Rocket 3.3 at Space Launch Complex 46. The countdown remains in a hold at this time due to an issue involving the conditioning of liquid oxygen. There's been no further explanation of that. The countdown clock in this view from Astra and NASA Spaceflight shows the clock holding at T-minus 31 seconds. Our clock provided by ground teams here at the Kennedy Space Center is actually at T-minus 1 minute and 10 seconds, so we don't know the reason for the discrepancy in the hold time of the clock. However, we do expect, if the launch is to proceed today, the countdown clock to recycle back to an earlier point a few minutes before this point in the countdown to recycle and restart a terminal countdown to target a new launch time. So we do expect to see the clocks cycle back perhaps as far back as T-minus 15 minutes to attempt a second launch attempt, a second run through the countdown today. Again, that assumes that this liquid oxygen conditioning issue is resolved, and also assumes that the weather conditions remain green for launch as they currently are here at Cape Canaveral. However, the forecast is for the conditions to deteriorate with storms moving in throughout the afternoon. As the clock approaches 1 p.m. Eastern Time here on Florida's Space Coast, the launch window for today is now halfway complete. The window extended from 12 p.m. Eastern to 2 p.m. Eastern, or 1600 to 1800 UTC. The Astra countdown remains in this hole that was called about a minute before the scheduled launch of the Astra Rocket 3.3 vehicle at 12:12 p.m. Eastern Time. So the hold has now been in place for nearly 50 minutes as Astra works through what they're referring to as a liquid oxygen conditioning issue. Liquid oxygen is the oxidizer used on both stages of the rocket. It feeds the 5 Delphin engines at the base of the first stage, as well as the single ether engine on the upper stage of the vehicle out at pad 46. And both stages consume that liquid oxygen in combination with kerosene fuel, RP1 as it's called, Rocket Propellant 1, which is a highly refined kerosene fuel. This mission is carrying 2 satellites into orbit for NASA's Tropics constellation. The Tropics constellation will eventually consist of 6 satellites flying in formation in 3 orbital planes to study hurricanes. This animation from NASA shows what the satellites will look like when they're in orbit. Each spacecraft is about the size of a shoebox or a loaf of bread, with a spinning radiometer instrument on the end that's about the size of a coffee cup. And these microwave radiometers will be scanning tropical cyclones to measure their moisture and temperature throughout the vertical column of the atmosphere inside and around hurricanes and tropical storms. And 6 of these satellites will be used in formation in 3 different orbital planes to fly over the same regions of the tropics about once every 50 minutes. And that'll provide a much more rapid and regularly updated view of what's going on inside hurricanes. You're looking now again live at pad 46 at Cape Canaveral Space Force Station from our vantage point about 5 miles away. The Astra vehicle, again, is relatively small by rocket standards, stands just 43 feet or 13 meters in height, and it's visible there on the horizon in between the 2 larger antenna tower-like lightning protection masts at pad 46. Those masts protect the rocket from lightning strikes while it's on the pad. To the left of the rocket is the large mobile service gantry that's used for some missions at pad 46 to stack different components of the rocket before launch. Astra does not use that facility. It brings in its equipment in its own trailers and sets them up independent of the mobile service gantry. You can also see some photographers and spectators gathered on Jetty Park's pier to get a view of today's launch. The weather parameters continue to be favorable, but the radar shows thunderstorms continuing to build and become more numerous inland across central Florida, and the radar shows them moving in the general direction of Cape Canaveral. As we await word from Astra on the progress in resolving this liquid oxygen conditioning issue that they're citing as the reason for the hold today, we're also watching the weather radar here on Florida Space Coast, which is showing a lot more activity than it showed a couple of hours ago, with more showers and thunderstorms developing inland across central Florida, moving in a general direction toward the northeast. There is one rain shower passing over the spaceport right now, but it's not passing directly over the launch pad. In our view from our location here at the Kennedy Space Center, you can see some rain clouds moving into view. On the right side, you can see a rain shaft, if you look closely, from that rain shower passing over Cape Canaveral Space Force Station at this time. But right now, the weather conditions remain green at this moment. The sky over the launch pad is clear for launch if the launch were to occur now. However, as you can see, the situation is dynamic. The weather situation is evolving, and the launch window extends until 2 p.m. Eastern Time, and there's no guarantee that the weather will remain go throughout that remaining 43 minutes of the window. And in the meantime, the other thing being tracked is the status of the countdown from Astra as they work to resolve what they're calling a conditioning issue with liquid oxygen on board the rocket out at Pad 46. We're now showing a live view of Astra's Rocket 3.3 vehicle at Pad 46, provided by Astra and NASA Spaceflight, which is streaming the launch for Astra. This shows the vehicle vertical, and oxygen vapors are visible streaming away from the vehicle as the rocket is more or less fully loaded with propellants at this time. The rocket fully loaded weighs about the same as a small business jet. The vehicle is 43 feet tall and 52 inches in diameter. And the 5 kerosene-fueled engines at the bottom of the rocket will be generating 32,500 pounds of thrust at liftoff. And once again, here's our view from 5 miles distance, showing the Astra rocket on the horizon at Pad 46. As I mentioned, the rocket is 43 feet tall. That's about 1/5 the height, approximately, of a SpaceX Falcon 9 rocket. And in fact, the entire Astra rocket is roughly the height of the payload fairing, the nose shroud, on a Falcon 9 vehicle. This makes the Astra Rocket 3.3 vehicle the smallest orbital class rocket currently in operation anywhere in the world. As we continue to wait for an update from Astra on the progress of their troubleshooting of this liquid oxygen conditioning issue, you're continuing to look at a live view of Space Launch Complex 46 on the left-hand side of your screen, a close-up view from a camera near the pad provided by Astra and their video streaming partner NASA Spaceflight. On the right, the view from our camera position about 5 miles away near Jetty Park, the closest available viewing site for us today. Because NASA and the U.S. Space Force are not providing access to photographers to a close-up viewing site for this mission, as they typically do for most launches from here on Florida Space Coast. So we've had to go to a position a little more distant than we normally do, and that's the view you're seeing on the right-hand side of the screen. If you want to support our coverage, you can go to spaceflightnow.com and click the Members tab near the top of the homepage. And any contribution to join our members program that you can provide helps us continue and improve our coverage of launches here in Florida and in other sites around the world. You can also go to shop.spaceflightnow.com and visit the Spaceflight Now store to collect patches and other memorabilia associated with historic and current space missions. Astra is setting up for another possible launch attempt today. The latest report a few minutes ago from Astra Launch Control said that the countdown clock will be recycled, and the team out at the control center at Alameda, California will be polled for a go or no-go to proceed into the terminal countdown once again this afternoon. There's also a check scheduled with the Eastern Range, which is run by the U.S. Space Force here at Cape Canaveral, to make sure that the launch hazard area is clear of all aircraft and boats, and also to check on the status of weather constraints and weather criteria as the weather this afternoon continues to be dynamic, with rain showers popping up inland and heading in the general vicinity of Cape Canaveral. One of those showers looked like it was going to be clipping the spaceport, passing over the spaceport a few minutes ago, but fizzled out just before reaching the coast. However, there are more showers inland pushing this way. So it's going to be a race against the clock for the launch window closure at 2 p.m., as well as the weather conditions, to see if Astra can recycle the countdown and make another run through that terminal count and launch before 2 p.m. Eastern Time. And the countdown clock has resumed now. We haven't heard officially that the launch team has been polled to go. We'll await that milestone in the coming minutes, but the countdown is ticking, targeting a launch time of 1:43 p.m. Eastern Daylight Time, or 17:43 UTC. As Astra counts down toward another launch attempt today, that liftoff is now targeted for 1:43 p.m. Eastern Time, or 17:43 UTC. This mission will be carrying 2 nanosatellites into orbit. These are 11 to 12 pound, or roughly 5 kilogram nanosatellites for NASA's Tropics mission, which is dedicated to observing and measuring conditions within hurricanes. These 2 satellites will be deployed into an orbit about 357 miles or 550 kilometers above Earth. This shows the major events expected during the flight. 5 Delphin engines at the bottom of the Astra Rocket 3.3 first stage will power the rocket off the pad with 32,500 pounds of thrust, burning kerosene and liquid oxygen. The rocket will be pitched over and head on its trajectory toward the east, beginning at t plus 6 seconds. It'll pass the speed of sound in less than a minute, and then at t plus 70 seconds, it will pass the moment of max Q. This is the period of maximum aerodynamic pressure on the vehicle during the climb through the atmosphere. Those 5 first-stage engines will continue firing until t plus 3 minutes. Those engines will then shut down, and the nose fairing on top of the vehicle will be jettisoned 5 seconds later to reveal the upper stage and the Tropics satellites. That'll be followed 5 seconds later at t plus 3 minutes 10 seconds by stage separation. The first stage will fall back into the Atlantic Ocean and won't be recovered. This is a fully expendable vehicle. The second stage engine will then ignite its single engine, producing 740,000 pounds of thrust at t plus 3 minutes and 15 seconds. That burn will last about 5 minutes, a little more than 5 minutes, to accelerate the Tropics satellites to orbital velocity of nearly 8 kilometers per second, or nearly 5 miles per second of speed. And that'll set the stage for deployment of the 2 Tropics satellites at t plus 8 minutes and 40 seconds. This map shows the approximate ground track of the vehicle. It'll be heading just north of due east from Cape Canaveral Space Force Station, launching from Space Launch Complex 46, which is the easternmost pad at Cape Canaveral, Florida. Now, less than 8 minutes until liftoff. You're looking now again live at Space Launch Complex 46. The Astra Rocket 3.3 vehicle is just barely visible there on the horizon, but we expect it to become much more visible once it clears the tower and starts heading downrange. This rocket, again, is 43 feet in height. It's the smallest orbital class rocket currently flying anywhere in the world. Now, inside of 3 minutes until launch, the final polls have been completed of the range and Astra's launch team, confirming that all stations, all parameters are green for launch. Weather conditions also favorable at this time for launch of Astra's Rocket 3.3 from Cape Canaveral Space Force Station. Now 1 minute and 50 seconds. T-minus 1 minute 45 seconds. In the next few moments, the propellant tanks on Astra's vehicle will be pressurized for flight. One minute to go. 1 minute until launch of Astra's Rocket 3.3 vehicle with NASA's first 2 Tropics CubeSats, beginning a mission for hurricane research. T-minus 20 seconds. T-minus 5 seconds, standing by for ignition and liftoff. And there is liftoff of Astra's Rocket 3.3, carrying 2 of NASA's Tropics hurricane research satellites into orbit from Cape Canaveral, Florida. Now T plus 1 minute, everything looking good so far in this flight of Astra's Rocket 3.3. Now approaching main engine cutoff. Good burn so far reported by the first stage. And there's main engine cutoff. Here's an onboard view showing, looks like we just had payload fairing jettison. And separation of the upper stage. This onboard view shows the upper stage engine. Astra's rocket now passing an altitude of 300 kilometers. Second stage engine is burning to place these two Tropics hurricane research nanosatellites into orbit. The first stage burn looked like it was a good burn. The 5 engines fired for about 3 minutes or so, and then the booster separated and the payload fairing jettisoned, and then the upper stage a few moments later separated and ignited its engine to begin this orbital insertion burn. This burn is expected to last until T plus 8 minutes and 30 seconds. This view on the left-hand screen shows the expected ground track for today's mission, heading again just north of due east, away from Cape Canaveral Space Force Station. On the right, an onboard view of the upper stage engine in space now as it powers into orbit with these two Tropic hurricane research satellites on board. Now approaching 7 minutes into the mission, good telemetry from the upper stage, continuing to show this live view from the upper stage, showing the ether engine in operation. The ether engine producing about 740 pounds of thrust. Everything going well so far in this upper stage burn, according to Astra. And now we see the velocity meter starting to decrease. This we'll await a word from Astra on what this means. This may indicate an early shutdown of the upper stage engine. We'll stand by. We're now about a minute past the expected time that we expected to see the cutoff of the upper stage engine. However, the feeds from Astra have gone silent. There was an apparent loss of attitude control, at least visually speaking. It appeared to be a loss of attitude control from the view that we had from an onboard camera on stage 2. And then we saw the telemetry velocity meter start to decrease, indicating that there may have been a problem with the upper stage performance, the upper stage part of the mission. So we'll stand by for a word from Astra on exactly what happened. Astra has confirmed that today's mission did fail during the upper stage burn. The engine shut down a little bit early, about a minute earlier than planned, and the 2 Tropics satellites on board were not able to be delivered to orbit today. Now 14 and a half minutes since the launch of Astra's Rocket 3.3 vehicle from Cape Canaveral, Florida. Astra has confirmed again that the mission was not successful. The 2 Tropics research satellites that were destined to study hurricanes from orbit did not reach orbit as planned. This was due to an early shutdown of the upper stage engine. That shutdown appeared to occur about a minute before the scheduled time of upper stage, second stage engine cutoff. And at that time, the rocket was not traveling fast enough to reach orbital velocity. So the upper stage and the 2 Tropics hurricane research satellites were expected to re-enter the atmosphere. They were already in space at that point. They're expected to re-enter the atmosphere and crash and burn up, likely in the atmosphere, somewhere over the Atlantic Ocean east of Florida, likely a few hundred miles downrange at least. At the time of the failure, the upper stage was at an altitude of about 300 miles or 500 kilometers and traveling at a speed of faster than 6 kilometers per second. But that's not quite fast enough to achieve a stable orbit around the Earth. So these 2 satellites will or are now re-entering the atmosphere likely and will burn up and be destroyed. This was Astra's 7th orbital launch attempt, and the company is now 2 for 7. 2 of those missions have actually successfully reached orbit out of those 7 attempts. NASA does have 4 more Tropics hurricane research satellites built and awaiting launch on 2 future Astra rocket flights. Those missions were scheduled to occur in late June and mid-July, but we'll see if those schedules hold now after Astra has encountered another launch failure. They may need some time to analyze the data and introduce and institute some corrective actions before their next flight. So with that, we thank you for joining us for our live coverage today from Cape Canaveral, Florida. We'll have further live coverage of launches later this week. There are 2 SpaceX missions scheduled to launch from Cape Canaveral in the next week from Pad 40 at Cape Canaveral Space Force Station, as well as Pad 39A at the Kennedy Space Center. So those are the next launches that we'll be covering live here in Florida. We'll hope you will join us for those. And until then, I'm Stephen Clark from spaceflightnow.com. Have a good afternoon.